This is 3i Atlas. This is Mars. 3i Atlas is about to swing by. Camera-ready rovers and orbiters are standing by to snap some pictures.
Something happened above Mars that no one expected. On October 3rd, 2025, the interstellar object 3i Atlas swept past the red planet. Fast, bright, and unpredictable. Instruments detected pulses, radiation spikes, and magnetic echoes that scientists still can't explain. The images remain hidden, the data mysterious. Let's uncover what Mars witnessed, what NASA isn't saying. Today, we'll find out what really happened. The flyby that changed everything. By the morning of October 4th, 2025, the excitement had turned into confusion. Mars should have delivered the clearest interstellar flyby data in history. Yet the silence was immediate. Orbiters had tracked 3i Atlas perfectly through its pass. But when the data reached Earth, something didn't add up. It was roughly 3 to 4 miles wide, moving at 134,000 miles per hour, fast enough to cross the Earth-Moon distance in just over an hour. The event was predicted to the second. Orbiters were positioned, rovers stood by, and ground-based telescopes were synced. Everything was set for one of the most documented celestial encounters in history. But hours after Atlas crossed Mars's orbit, a strange silence began to spread through the data channels. NASA, ESA, and every major observatory are expected to release their first Mars-side images within 24 hours. Instead, nothing. No photos, no press briefings. Just confirmation that data acquisition was successful and analysis is underway. Those are the kind of phrases scientists use when something in the data doesn't fit expectations. Early readings hinted that Atlas behaved oddly as it passed Mars. Its light curve, the graph that tracks how bright it appears, didn't rise smoothly. It pulsed in irregular beats, like something was flickering inside it. Not random jets of gas, but rhythmic surges spaced too evenly to ignore. Even stranger, Mars-based instruments picked up minor fluctuations in charged particle density right after the flyby. Subtle, but measurable. MAVEN's magnetometer registered small blips, and Perseverance's radiation sensors noticed a brief spike. Those readings could be a coincidence or a sign that Atlas's tail interacted with Mars's upper atmosphere in ways no one predicted. Scientists now face a mystery in plain sight. We know the object passed. We know the instruments recorded. We don't yet know what they saw, but everyone knows something changed that night. Some astronomers suggest it was just volatile gas flaring up as sunlight hit Atlas's surface. Others aren't so sure. The object's emerald glow, its carbon-heavy spectrum, and those pulsed brightening patterns don't align neatly with known comet behavior. As of now, no high-resolution photos from Mars orbiters have been released. And that's feeding theories. Everything from government data holds to wild claims about engineered motion. Either way, it left everyone asking the same thing. What did Mars just witness? Days later, the silence still lingers. Usually, by now, we'd have stunning composite shots plastered across space agency feeds, detailed analyses, color-corrected frames, and big headlines. Instead, there's a pause, a deliberate one. Whatever those orbiters saw, it's taking time to process, and that's exactly why the world is watching. Because this isn't just about another rock speeding through the void. It's about the first interstellar object ever observed up close by another planet. And something about it doesn't add up. And so, we wait. Not for speculation, but for proof. Locked somewhere in those unreleased images sitting on servers in Pasadena, Darmstadt, and deep space relay stations. The world wants to see what Mars saw that night. And when those pictures finally drop, they might answer the question that's been echoing since the flyby. Was 3i Atlas just a comet or something deliberately passing through? Let's talk about what those hidden images might show, and why their silence might be the loudest clue of all. The silent delay. It's been days since the Mars flyby, and people keep asking the same question. Where are the photos? But maybe that's the wrong question. Maybe the answer isn't in the pictures themselves, but in the data that's quietly trickling down from Mars. You see, before any image becomes public, it passes through a mountain of processing. Signal cleaning, calibration, cross-referencing between orbiters. Normally that takes hours. This time, it's taking much longer. According to mission insiders, the raw telemetry from orbiters like MRO, MAVEN, and Mars Express didn't just capture visuals. It captured unusual readings alongside them, and those readings may explain why the pictures are on hold. Complicating everything was the solar conjunction window, that stretch when Mars drifts near the Sun from Earth's line of sight. During conjunction, radio interference peaks, downlink speeds collapse, and data often arrives garbled. For engineers, it's a logistical nightmare. For skeptics, it's a convenient excuse. Either way, it's the perfect cover for a delay, or a perfect explanation, depending on how you see it. Let's start with the spectral data. Instruments tuned to measure gases and light from the comet's coma detected anomalies in the ultraviolet and infrared range, spikes that didn't match known comet chemistry. One MAVEN scientist described them as brief, narrowband flashes, not the broad emissions expected from sublimating ice. In plain terms, something near Atlas was emitting in a pattern, not just reflecting sunlight. Then came the radiation data. As the object passed Mars, MAVEN's particle detector logged an uptick in high-energy particles, short bursts that faded as quickly as they appeared. At first, engineers thought it was solar interference, but the sun's output was steady that day. The spikes lined up perfectly with Atlas's trajectory. Add to that the electromagnetic irregularities. Brief magnetic field distortions recorded around the same time by both MAVEN and the trace gas orbiter. Those can happen when dust interacts with charged particles, sure, but the patterns were too rhythmic, too synchronized to be random. Now, picture what this means for mission control. You've got orbiters sending not just images, but telemetry that says something active might have brushed past Mars. Suddenly, those raw frames aren't just pretty pictures, they're potential evidence. And that means every pixel must be verified before it's released. So, while the world waits for photos, scientists are digging through the data first, because it might hold the reason why those images are being delayed. Maybe they caught a strange glow, maybe a heat signature that shouldn't exist, or maybe something is moving in ways a natural comet simply doesn't. Whatever the answer is, it's in the numbers. And that's exactly where astronomers are looking right now. Because when those verified images finally appear, they won't just show what Atlas looks like, they'll show why Mars went silent. Signals beneath the red dust. While orbiters were busy chasing light curves and magnetic ripples from above, Mars itself was listening from below. The rovers, the weather stations, even the radiation monitors all kept their sensors running through the night of the flyby. And what they recorded is now raising quite eyebrows inside mission control. Let's start with the Perseverance rover in Jezero Crater. Its radiation assessment detector, RAD, logged a brief cluster of spikes a few hours after the predicted closest approach of 3I Atlas. Each pulse lasted less than a minute, spaced just far enough apart to look deliberate, but not long enough to confirm a solar storm. When engineers cross-checked with Earth-based monitors, the sun's output was calm. Something local had brushed Mars's thin atmosphere. Meanwhile, Curiosity's environmental suite detected a short-lived rise in high-altitude dust particles, almost like the planet had been dusted from above. The particles weren't typical Martian dust. The spectrometer hinted at traces richer in carbon and nickel than anything usually found in the crater air. Scientists are cautious. It could be contamination from the instrument, but the timing matched the Atlas pass within an hour. Then came a subtler clue. The InSight lander's seismometer, though mostly silent these days, picked up a faint hum, a low-frequency oscillation that didn't match any wind event or mechanical noise in its logs. It's likely nothing, just background resonance, but its timestamp lines up eerily with the same atmospheric flutter recorded by MAVEN from orbit. Coincidence? Maybe. But coincidences stack up fast when every sensor twitches at once. Even the Mars Color Imager aboard MRO noticed a faint greenish haze over the northern hemisphere for several frames. A hue shift so delicate it would have gone unnoticed if analysts weren't already combing through data. That tint lasted minutes, not hours, and hasn't reappeared since. Some think it was an auroral glow triggered by charged particles from Atlas's tail colliding with Martian gases. Others say it's just calibration noise. Even astrophysicist Dr. Avi Loeb noted in his preliminary report that Perseverance's stacked frames captured a faint fast-moving streak exactly where Atlas should have been. He described it as a detection that confirms position but deepens the mystery. None of these readings alone proves anything extraordinary, but together they form a pattern. Small, consistent deviations that all trace back to the same moment. The night an interstellar object swept past Mars. For now, the official word is under analysis. But behind the scenes, engineers are piecing the clues together. Radiation, dust, color shifts, to see whether Atlas simply passed by, or touched Mars in ways we don't yet understand. And if these whispers from the surface are real, the next question is even bigger. What did the planet's orbiters see at the same time? Because their synchronized readings could finally tell us whether these were just cosmic coincidences, or the fingerprints of something far stranger moving through the Martian sky. The anomalous glow. While Mars's instruments were still processing their strange readings, telescopes back on Earth began to notice something that didn't fit. For nearly 48 hours after the flyby, 3I Atlas continued to shimmer. Not randomly, like a comet shedding dust, but in a pulse, a heartbeat of light, repeating every few minutes, bright enough for even mid-range observatories to track from millions of miles away. At first, astronomers called it a coincidence. Sunlight bouncing off uneven ice patches, maybe. But the light curves told another story. Instead of fading as Atlas moved farther from the sun, it briefly intensified, flaring in the direction opposite of its predicted dust tail. That's backwards behavior for a comet. Something somehow was emitting light where it shouldn't. Then came the color problem. The emerald tint that earned Atlas its nickname began to shift. Amateur astrophotographers in Chile, Spain, and Hawaii independently reported the same thing. The glow wasn't pure green anymore. It flickered blue-white, sometimes orange at the edges, before returning to green again. Those hues matched the spectral fingerprints of ionized metals, magnesium, nickel, and sodium, but in ratios that don't match any known comet chemistry. Meanwhile, Mars orbiters that still had telemetry connection detected similar wavelength anomalies. The trace gas orbiter's UV spectrometer caught fleeting ultraviolet emissions that spiked in narrow bands, the kind that normally point to energetic processes like electrical discharge or plasma flow. If that's what it was, then Atlas wasn't just reflecting light, it was interacting with its surroundings. Some scientists quietly suggested an induced aurora, a temporary glow triggered when charged particles from Atlas's tail met Mars's patchy magnetic field. That theory fits part of the data, but not the timing. The emissions were too regular, too structured, and so the debates began. Was the glow an optical illusion caused by dust and magnetic turbulence? Or was it, as one astrophysicist carefully phrased it, evidence of coherent activity from a non-natural source? No one's made that claim publicly yet, but when the same pulse pattern shows up in multiple instruments, optical, ultraviolet, even radio, coincidence becomes a hard word to defend. Whatever this was, it didn't behave like a comet that stumbled into sunlight. it behaved like something that knew how to manage it. And that's why mission scientists are now focusing on the trajectory data to see whether Atlas's path shifted in sync with those pulses. Because if it did, that glow wasn't just light, it was motion. Deliberate, directional motion, and Mars may have been the first planet to witness it. Whispers, behind the data delay, inside mission control, celebration had turned into analysis. The night after the flyby, engineers sat under the soft hum of servers, replaying streams of raw telemetry from Mars. Instead of routine comet data, they found patterns, tidy, repeating bursts where randomness should have lived. The kind of detail that forces teams to stop, stare, and start the review process from scratch. No official statement has confirmed it, but those inside the loop say the Mars data channels were quietly flagged for restricted access. Normally, readings flow straight into NASA's open databases within hours. This time, they didn't. The label attached to the delay read, "Pending anomaly verification." To most people, that sounds harmless. To data engineers, it means something in the numbers refuses to make sense. From there, things got even stranger. One internal log showed synchronized fluctuations in two separate orbiters, MRO and MAVEN, at the exact moment Atlas crossed the red planet's orbital plane. The pulses weren't identical, but they mirrored one another too neatly to call it coincidence. Some researchers thought it might be electromagnetic interference. Others weren't so sure. By the third day, word had spread across agencies. An inter-office memo from ESA mentioned optical variance persistence, bureaucratic code for a light source that refuses to behave. Over at Jet Propulsion Lab, analysts began layering datasets to search for a pattern. If those pulses lined up across instruments, it could mean the readings came from a single source. Meanwhile, outside those walls, astronomers noticed something unusual too: a total blackout of new Mars telemetry. Amateur trackers monitoring the Deep Space Network saw the usual open access pings go silent for hours at a time. Nothing sinister, just missing. NASA's public response stayed calm. Data review in progress. ESA echoed the same message, adding that data integrity review is underway before publication. Both agencies insisted the pause was procedural, though the timing, right after the anomaly memos, only deepened the intrigue. The tension in the community said otherwise. A handful of independent researchers hinted that the orbiters might have captured reflective movement, a flicker that seemed deliberate, like sunlight bouncing from something smooth, not dusty. No one's crying alien yet. But the precision of these delays, the coded language in internal notes, and the synchronized anomalies all point to one thing. The agencies are double and triple checking every pixel before it leaves the lab. Because if those withheld frames reveal an object that changes course in rhythm with its own glow, that's not a calibration glitch. That's the intent. And intent, in space, changes everything. If the pictures ever drop, imagine the moment those images finally go public. The high-resolution frames from Mars orbiters, the calibrated spectral graphs, the side-by-side comparisons. It's the kind of release that could either settle the debate or ignite a new one. Because what those pictures show, or don't show, will define what 3i Atlas really is. Inside the scientific community, 3 scenarios are already being whispered. The first is the natural case, the safe one. In this version, Atlas is just a bizarre but explainable comet. Its pulses come from buried pockets of carbon dioxide venting under sunlight, and the strange brightness patterns are reflections off metallic dust grains. The photos, if that's true, would show a fragmented surface, a rough shape, and maybe a faint coma around a broken nucleus. Unusual, yes, but still within the realm of nature. The second scenario is far less comforting: catastrophic fragmentation. In this case, Atlas didn't glide past Mars. It cracked apart. If that happened, the orbiter's cameras might have caught debris fields orbiting the planet's vicinity or small fragments trailing behind. That would explain the sudden magnetic fluctuations recorded by MAVEN and the brief radiation spikes seen on Perseverance's sensors. Scientists quietly admit this version could create micrometeoroid hazards for Mars orbiters if the debris remains in its path. Then there's the third scenario, the one nobody wants to say out loud in official reports. Artificial structure. A repeating glow, a polished reflection, or a geometric symmetry visible from orbit would change everything. It would mean the pulses weren't random outgassing, but controlled energy releases, like course corrections. If those patterns appear in the images, they'll challenge every assumption about interstellar objects we've ever made. Behind closed doors, data analysts are already preparing public briefings for all three outcomes. The talking points are written, waiting, ready to explain away the extraordinary if it appears. But among scientists, there's quiet recognition that no matter what the explanation turns out to be, Atlas has already made history. And when those pictures do appear, they won't just answer questions, they'll raise new ones. Because the story isn't only about what Mars saw, it's about what we didn't. Why did an interstellar object pulse in a rhythm that mirrored artificial modulation? Why did the data channels stall? And why are so many instruments pointing back to the same strange moment? Whatever the reason, those images will do more than capture a comet. They'll capture a turning point. And once they drop, science won't just be explaining the universe. It'll be defending what it thought it knew about it. Mars, the silent witness. If Earth were blind during Atlas's closest pass, Mars wasn't. For one brief moment, the red planet became the solar system's lookout, its silent witness. From orbit to surface, a web of instruments recorded everything they could. And now, those recordings may hold the only first-hand evidence of what really happened. The irony is hard to miss. For decades, Mars has been the world's science project, our testing ground for rovers, cameras, and sensors. But on October 3rd, 2025, all that hardware suddenly had a different purpose. It wasn't just exploring, it was watching. Each spacecraft had a job. MAVEN monitored charged particles. Mars Express tracked gas composition. TGO scanned the upper atmosphere for chemical changes, and MRO pointed its powerful HIRAS camera toward a tiny, fast-moving target gliding past in the black. On the ground, Perseverance, Curiosity, and other surface assets recorded environmental shifts, dust patterns, radiation, and even faint magnetic tremors. Individually, these readings might not seem like much. But combined, they create a timeline, a planetary logbook of something extraordinary crossing the Martian sky. According to preliminary reports, Mars's ionosphere, the layer of charged particles that wraps the planet, fluctuated right as Atlas passed overhead. The data looks like a heartbeat, 3 rhythmic spikes matching the object's brightness pulses recorded from Earth. Coincidence? Maybe. But scientists know better than to dismiss patterns that repeat across instruments and distances. Even the Trace Gas Orbiter caught a subtle shift in methane and carbon dioxide levels high above the planet's surface. Not much, just a chemical hiccup. But it happened at the same time as the radiation spikes. Mars doesn't produce changes like that without a trigger. And that's why Mars is now at the center of this mystery. It's not just where Atlas was seen, it's where it left fingerprints. Every reading, every fluctuation is now being cross-analyzed to understand what actually brushed the planet's atmosphere that night. In the coming weeks, scientists will reconstruct the encounter second by second, how the light changed, how the air reacted, and whether something from that interstellar traveler lingers still. Because if 3i Atlas interacted with Mars, even briefly, it means an object from another star system just touched a planet in hours. Mars won't tell us what it saw. It can't, but its data will. And when those results are finally decoded, the red planet may hold the first concrete clue to whether Atlas was a natural wanderer or a visitor on purpose, waiting for the truth. It's been days since the flyby, and still, the world is waiting. The data is in, locked in servers, encrypted across mission archives. But the story it tells hasn't been spoken aloud. The scientists know what's in those files. The public doesn't. And that silence is starting to sound louder than any official statement. What we do know is this: every instrument pointed at 3i Atlas recorded something out of place. Brightness curves that pulsed, radiation levels that spiked, spectral signatures that didn't match any known comet recipe. Each anomaly alone would have sparked curiosity. Together, they've built the kind of tension science rarely admits in public. Inside the agencies, teams are dissecting the data frame by frame. MAVEN's particle readings are being compared with Hirisi imagery. TGO's spectral bands are cross-checked with Perseverance's radiation logs. The goal is simple: to make the unknown behave like something known. But what if it doesn't? Even now, some mission insiders hint that the final dataset could redefine expectations for interstellar matter behavior. It's the kind of phrase that sounds routine until you realize what it means. They saw something no one expected. Meanwhile, Earth's telescopes continue to track Atlas as it drifts farther from Mars. Its light has dimmed, but not evenly. Every few hours, the object flashes again, faintly, like a heartbeat fading behind cosmic static. Astronomers are logging the timing, and the pattern still holds. 3 pulses. Always 3. Could it be natural? Absolutely. Space is full of surprises. But what unsettles scientists most isn't what Atlas did. It's how perfectly it did it. The rhythm, the color, the geometry. Everything fits too neatly into a pattern. As for the images from Mars, word is they're close to release. The teams are finalizing corrections, filtering out noise, and verifying timestamps. But everyone knows this won't be just another Comet press briefing. When those photos appear, they'll either confirm everything we feared or prove how easily the universe can trick us into seeing intention where there is only chance. The next step belongs to the James Webb Space Telescope and a network of deep space radio arrays. Over the coming weeks, they'll continue monitoring Atlas as it slips beyond Mars's orbit, searching for any lingering heat or radiation signature that could validate what the Martian instruments first detected. If even a trace aligns, the mystery of Atlas won't be finished. It'll just be moving farther from home. Until then, all we can do is wait. Wait for the frames. Wait for the analysis. Wait for truth to catch up with curiosity. Because maybe this was just a comet, an icy fragment passing through our system on its way home. Or maybe it was something else. Something that saw Mars, turned slightly toward it, and left without saying a word. Are the pictures delayed? Or are they revealing more than we expected? Drop your thoughts in the comments. What do you think they're hiding? And don't forget to like, share, and subscribe for more cosmic investigations.